projects. One project is my Django project, which will run through some sort of WSGI service. And then I've got my front-end project, which is statically posted, so it doesn't need WSGI, it doesn't require model pipe, it doesn't need Apache, it can be served through S3 bucket. You can host it through your own Linux server. It's very, very small site. And this is basically it. You have one index file, which is going to be base HTML. It's got a div which has a root ID, you put it in you want, and it links through to a bundle.js file. That's it. Now what happens is the bundle.js file, it's minified, obfuscated, it's got all your JavaScript code, it's got all the JavaScript libraries that you use. It's got, if you wish, your embedded styles, so if you've got Sass rolled into CSS, that's included inside that file as well. And you can even encode and put images in that file. The few applications that I've written with this technology that I'm going to get into, this bundle file sits between normally 2 to 4, maybe 5 megs a week. So it's not a big, don't see it as a huge big one at any time, but it's quite nice. Right, so for those of you that don't know ES6, it's the new version of, obviously, like other languages, the syntax for JavaScript is constantly being improved. So ES6 came out, and what it does is it starts changing the landscape of your UI. I know a lot of backend engineers hate working with frontend, find the prototypal syntax a little tough. So what's happening is JavaScript's really coming in to its own. You're starting to get proper class syntax. And given functional programming, I don't know Scala or some other languages, really finding that Scala and JavaScript, even their syntax, arrow functions, even with Java, is really starting to make your language a little bit more short and concise. So because of the functional angle, you are getting things like arrow functions, you're getting things like chaining, generators, iterators, and some of the other things that you see in other languages. The bad thing is that not all browsers support the latest version of JavaScript. We've always battled with cross-browser support. And especially in our world, we've got TVs, smart, for example, Samsung has 2 TV platforms, Orsay and Tizen. Tizen's a new one. Orsay is pretty old, and their browser support is quite like both performance and JavaScript version. So how can we write a really good, strong application, but using an older version of JavaScript? And that's where Babel comes in. Babel will take your JavaScript. So if you write it in a new format with the arrow function functional, it will actually convert it into a proper anonymous function and explicitly return N+1. Something else that we use is NPM. Does anyone use Node? Node and Node.js. So most of you then know NPM. It's just a really good package manager for JavaScript. Not for Node, you don't have to use it. You don't have to use Node, sorry, in your stack. So all it really does is allow you to get all the little JavaScript libraries that you need and put it into a local folder in your project. And as I said, once you've done your builds and everything, you don't have Node, you don't need to run Node. I use Node in my applications just to help me with my dev server, and I can do some very clever things with hot module reloading. If I'm going to change styles, I don't have to refresh my browser. So this is what an NPM package looks like. The important things is there's some dev dependencies and some dependencies when I go into production. It does all my version management for me. And it gives me some links into running my tests, running my web server. It just gives me some commands that I can write to help me when I'm running my project. So this is an example of my main index file. The top 2 imports are importing React and React's DOM, virtual DOM manipulator. Because there's no dot notation, it actually goes and fetches that from my nodes module, where my libraries are. Kind of like assign packages for Python. And then if I do have dot notation, it just means it's going to get it from my source code. And so I put in my own application router. And then what I do is those are familiar. Strap font, awesome animated style. those I import so that they get included into my bundle.js file, and that I can use them within my code set. And then I just call the React DOM renderer, I give it my app router, I'll talk a little bit about the markup, and then I link it to my unique group ID for my app. So that code will basically inject what I need to into my that little static index.html file and my app and so on. Okay, there's a few build tools that you can use in JavaScript. There's grunt gulp, require.js. The one that we've been using is Webpack. And what it does is, it's the thing that actually goes through, it knows about Babel, it knows about React, it's got these loaders. And it just manages the collection of all my assets. So it will run through my JavaScript files. This allows me to, if I change my code, it will automatically refresh it in my browser. It'll run it through Babel, so it'll dumb it down a bit. Where's my source code? This will look for my CSS, this will look for my Sass, and then it'll also find any of my media assets that I might want to include in my project. It's the same config file. It's got a few entries. This is just telling me that when I run my npm, so I'm going to run my project through Webpack, it's going to start up my dev server on that port, and it's going to go in and it's going to use my index file as my main loading file. Output-wise, if I run a build, it's going to put it in a dist folder, it's going to output to bundle.js, and it will include any files. And these are my plugins for hot module replacement. And then because I'm using React Bootstrap, theming, I've got some requirements for jQuery still, so I just make them globally available as a provider. Okay, so React. It's basically a component library, and it's obviously specifically used around user interfaces. The cool thing is it does play well with others. So if you use web components, or even if you use a backbone, for example, as another framework or Angular, you can still use React in a certain way. So it does play well. It's just a library. The important thing about React is, or the difference really about React and something like web components is web components will provide a strong encapsulation for usable components, where React just provides a library that manages your DOM and manages data. So this is a very simple component. I have a class that extends a React component, and on render, it's going to return a div with saying hello, and it's going to read out of my JavaScript class a property called name. You call the React render, and then you pass it your class, and you'll mount it on some node. I'm going to get to that pretty soon. This is a slightly more advanced example. This one starts managing state of your component. So on a constructor, your state is a tick with seconds elapsed set to 0. Every time a ticker goes off, it'll call set state, and what happens is you get your previous state, and you can do something with it. So in this case, seconds elapsed, we're just going to take whatever it was, and we're going to add 1. When the component mounts, it calls set interval. It's a standard JavaScript function, and it just maps it basically to my tick. So every second, this function is going to get called. When the component closes, it's going to go through an unmount, and we're just going to clear the interval and unmount the component. And now I've got my render, which is just going to output my state. Okay, so it's quite pretty straightforward. So a component has a life cycle. So when you mount a component, so that's when your component gets injected and put to the DOM, it'll run through this flow. Constructor component will mount, renders, and then it says component did mount. So it's almost like a pre and post hooks. Very similar to the sequence that you get within Django. And then if its state gets updated, so if something's happened and we will update some sort of attribute, it goes through this flow. Component will receive props, which is the new properties. Should it update, so maybe the property change doesn't mean that the component needs to re-rend. render. So it could fail like that. We'll render and we'll call component developer. And then there's a simple one for unmounting the component. Okay, so let's go into JSX. Alright. So when I saw this for the first time, I thought, oh, I'm going back to PHP and JSP where you're starting to mix markup and code. And I think one of the ways that I word it is JSX is HTML encoded, not the other way around. So you don't have this HTML doc and then you have this weird breakout brackets and then you start doing code inside. It's not that way. It's you'll see it's a little bit more cleaner. You don't have to use JSX, by the way, with React. You're more welcome to just stick with the older standard of working with the DOM, but it does make the output and the code a little bit more concise. So this is kind of how it looks. I've got a component, I've got a render function, and it returns, and that's basically JSX. It's HTML markup, but there's some little differences. You'll see it doesn't say class equal header, it says class name equals header. You'll notice the style actually passes through a JavaScript object. There's double squiggly brackets. The first squiggly bracket says break out of JSX and go into JavaScript mode, and then the second bracket obviously denotes the JavaScript object. And then you'll see here there's another single bracket, and I can inject the property type. So you can use React on its own. It's just a component. It's straightforward. A component can manage its own state. But in bigger systems, where you start using things like MVC, you start getting to quite a common problem where there's lots of weird little dependencies. You might be reading stuff from multiple models. One model in one view might be cached. So Facebook came around. There's a really good talk on a slide or two. There's a link that you can Google for. And Facebook had quite a serious problem with state management. They had their main website. They had the notification bar at the top if you got messages. They had a pop-up message thing you could chat on, and you had full screen. And what happened was sometimes you would mark or read a message, but the icon at the top would remain as red. And that was just around state. It was quite a hard bug to find, and that's when they came up with the Flux pattern. So it's driven from Facebook, and it complements React quite well. And basically what the Flux pattern drives, the main thing that you need to understand about it is it's a unidirectional flow. So that's often what you get with an MVC. Even within one application, you'll often get a direct model to view, but sometimes you'll get a composite view where you've got an account, and you've got a list of patients and doctors, or if you in that type of application, and you in one view you want to try and gather a lot of that information, so you start getting this cross-model view dependency. This is just a link, so if you're on YouTube, there's this title called Hackerway, Rethinking Web Application Development. A really nice talk to understand Flux and to understand the reasonings why and how they're implemented. So as I say, it's a unidirectional flow. So an action is just, it's very simple. It's just a JavaScript object. It's got a type field, and that type field has a string. So load patients, we'll say type colon, load patients, that's an action. And what you do is that action gets dispatched. The dispatcher is responsible for sending that action to the store. The store is the core to Flux. It manages your application state. So if you've got a view and you want to load a patient, at the beginning the store will be empty, the patient will be set to null. Once you actually get your patient from your backend and you load it in and you attach it to your store, the patient would be set to some sort of JSON object that represents your patient. And then the view will listens to events or listens to the store. So as soon as the patient gets set, the action load patient success is triggered, the view will get the update and the patient will automatically be loaded into your DOM. So Redux is Flux, but it's basically a functional composition version of it. stored sets. So instead of having callbacks in and around your code, Redux, the way it's structured, you just do a functional component, and I'll show you, composition, and I'll show you in some sample code what it looks like. The design around Redux was around 3 principles. The one was a single source of truth, which is your store. So if you ever need to get a state for your application, it's within your store. Second principle is the state is read-only. So a view can't just go into your state and update an attribute. It has to dispatch an action. And the third principle is changes are made with pure functions. So when the action is dispatched and hits a store, that information gets passed on to something called a reducer. A reducer is just a pure function which can then manipulate that state. And that's basically what an application using all of this technology looks like. So you've got a user that connects and has a view. The view could be, it could have a menu panel, a menu component, a header component, maybe a main component that's showing a list of clients. If you click on a button, the button will dispatch an action. So if I'm going to say add patient, the button doesn't actually try and show modals or anything, it just dispatches the action. The dispatcher, I'll get to the middleware, the dispatcher of create a new patient goes into the store. The reducer sees that this someone's wanting to create a patient, and it'll change the state of the store to say, maybe use a better example, like go and fetch patient details. The reducer will set the store state to busy loading client details or something like that. What happens is in the middleware, there's two ways in which you can work within this. Note that the reducer only changed the state of the store. There was no side effects. Okay. It just worked on the store, just changed its state. The middleware is the thing that will go off to your API and go and get the actual patient .json file. Sorry, the patient object. There's two ways you can do it, one through a promise and one through observables. And I'll get to a little bit about the differences in a couple of slides.
So your store is not just the store for whatever model the API returns. It's you're actually tracking through the store the actual state of the application.
Yeah, so you often
raise the event, reduce it, store it.
Yes.
Activate the middleware and listen to that, does whatever it needs to do.
Yeah, so on the success of a promise, if you get a promise successful, then you would dispatch an action which says patient delivered.
Which would again go back to the store.
Yeah, exactly.
And then actually store the patient, presumably,
Yeah.
which then triggers the components to listening to the store.
That's it. So when you dispatch the action and the action comes in, especially through the middleware, the action type of load patients on success will come through and attach to it with the patient. And then the reducer will update the state and go cool and attach the patient to the store. When you see it in code, you'll understand. So I think this is actually the last bit of tech that I want to talk before I switch to demo, which is RxJS. RxJS is quite a complex library. I don't think anyone's used it. Basically, what it does is it helps you set up a observable pattern. So it handles all your asynchronous calls and any event-based stuff that happens. There's some really nice talks on. I'm going to see if I can find one that I watched a few weeks ago, which just shows you about the library and it just says don't stress about its complexity. And there's a handful of operators that you can use. If anyone's done functional programming, you kind of start with like map. Some sort of map use function.
Sorry, RxJS, is that reactive extensions? Or
yes.
I'm getting quite confused with all those reactive extensions and like what's what?
It is, in fact, it's just being rewritten, I think. So even that's pretty confusing. You'll see there's a few links if you search for
So that's
RxJS. You'll see the reactive IO website,
okay.
and then you'll see a link to the GitHub site where it's almost like a sub-project. And now there's this new version that's being rewritten.
So is that like basically just a copy of the .NET reactive extension?
I believe so.
There's also an RxPy library.
There's a Python, there's a Java one, that's all linked through the same. So the way I use RxJS is with a package called React. I think it's called React Observables. It just wraps the RxJS and it just helps you manage the link. It just helps you